Boom. Hello, this is just an addendum to the last episode 29 of this Clojure study group. Had a bit of a failure in technology, so I'm going to cover how to do how to use regular expression to process the book contents of a book and find the most common word used in the book. And so we get to use regular expression. So a couple of examples using regular expression in there to see the book, to see how we can kind of manipulate the contents of the book. There we go. So here we've got a book. I've evaluate the book, which is just going to slurp in, just going to read in all the text of the book from this file, and it just creates just one big string of the book. And rather than having just one big string, which you can't really do much of, we want to break it into words. So this is what we're doing with this reseek here. So we've got reseek, which is a very common function we'll use with regular expressions. So it's going to use a regular expression to create a sequence. And our regular expression, as we learned in the previous video, is all the letters from A to Z, lowercase, and A to Z, uppercase, and all the numbers between 0 and 9. And then, we've got this colon here that if we, sorry, comma there, that if we come across a word like don't, which has an apostrophe, then we don't want to have two words like this. We don't want to have two separate words. We want to return a single word, don't. So that's what the or apostrophe is doing in this case. So it basically just gets all the cases. Although I've noticed that there's a problem with that, because there's this Arlingtonians, which has got an apostrophe at the end, and that's getting merged with the for. So there's still some tweaking of regular expressions, but in the main, it's getting this. Oh yeah, so it's getting so return don't return that as well. So it's getting the Hitch Hikers, which with an apostrophe, back as a single word rather than kind of breaking up into two words, which is what we want. And there we go. So here we've got, so that's the first reseek. That's the first part of this threading thing there. So we've got basically a list of the individual words, but we can't really, we'd have to still read through the entire book to be able to figure out what was the most common word. So we can do something called frequencies, which is a very nice function to be able to see. We've got a list of things, and what is the frequency in the whole of this list of the words. So here we've got of once here and of twice here, and probably many more times. So if we use frequencies, so that will be the same as doing frequencies around this function, then we can then see how often each of these words are appearing in there. What did I do there wrong? There we go. So mounting is one. Is there any words popped? Centipede. Some interesting. Blue's only got 7. That's interesting. And you can see that there's there are similar words there, so we might want to do something to combine those, gelt and jelts at some point, treat them equally. But for now, I think we're okay. But none of these are actually in order, so we still don't know which of the values to get, which is the most common one. And if we can take that, which is now a map, because we've got the string as the key of the map, and the number of times that string occurs in the book, that's the value. So we've got this key value pair, and using a map is a great way to express that. So that's what the frequencies has done. It's taken the list of strings and created a map with each string and the number of the frequencies that occurs in that in the overall list. So let's sort them now. So we can sort. We're sorting by value. There's no point if we sorted it by the key. It would just sort them like alphabetically, the strings alphabetically, which wouldn't really help us. We want to know which has got the biggest value. So we sort by val, which is the value in the key pair, and so that would be the same as doing sort by val. And let's slip that. Nope. Slip that in. So I'm just evaluating these as pretty prints, so it comes up in a separate window because it's quite a large file, quite a large output. Pre-printing is also helps it easier to see the structure. So here we're putting in, so sort by values, returning each of those things as its own vector, basically. So we've changed the data structure again, this time to give give a structure that's kind of ordered in that way, and then unfortunately it's showing us the lowest occurrences first, so we'd have to scroll all the way to the end to do that, but we can do that programmatically by just simply taking that and reversing it. So putting reverse in front of everything here. So it's going to reverse the entire data structure. And surprisingly enough, the biggest, the most common word is the. And in an English language book, that's not that surprising, I guess. Let's make that a little bit bigger. The, of, to, and they're all quite common English languages, English language words. So we want to find out what is the most common word without all the kind of the's and as and it's and so on. We can use another regular expression here. So I've written another threading macro here that will, again, we're going to pull in again, like we did with the Hitch Hiker's Guide to the Galaxy book. We're going to pull in some common English words. I just found these on the internet. Here's just this text file with common English words, and they're in a comma separated list. So if we look at the common English words, it's just a comma separated list in here. So we want to take these. Oh, twas. There's some interesting words in here. There we go. I don't think twas was very common. Maybe a while ago. I think this is short. Like usually, it was short for that. But there we go. And let's go back there. So we've got those common English words, and because they're all comma separated, we want to create that into basically a different data structure. So we want to change, transmogrify, we want to adapt the data structure into something that's more usable. So we're going to split all the words by using a regular expression. So I'll write this out in the normal form as well. So we've got slurp of the common English words dot text, and we're then doing a closure. Can't type anymore. Closure string split. So using a function from a different namespace, so we have to explicitly say that what it is, or include it in. We could include closure.split in this namespace definition as required, but if we're only using one function, then it's fine for doing it here. And we've got our regular expression, which is our pattern. Oops. And that is it's not a space, but it's a comma. So all the words split by comma. So that's how we want to do that. So it will remove all the commas and create individual strings from that. So let's do space K, slurp that in. Ooh, there we go. In there, so it's a bit easier to read on the screen. And so we're going to take the slurp in the words. That's just be will just be one big string, and then we split them with the regular expression. And oops, did I break something? What did I do wrong? Oh, did I do it the oh, yes, I did it the wrong way around. Yes, that's what I did. Yeah, so the error message there was that it can't use a string as a regular expression. I put the order of split. If we look at split, here down the bottom it's saying we want a string and then a regular expression. So I have to switch the order of these around. There we go. So now that should work. Yep. So instead of being a comma separated list, now they're all individual words, and we don't really. So we could use that as they are, but it's quite nice to put them into a data structure because that's a bit more that's unique. So we can use set because like there might be duplicates in here as well, and if we want to kind of put some efficiency in it, we can wrap the whole thing in a set, and it also kind of sometimes make it easier for comparison as well. So if we slurp that in, so this will create a nice set of our unique values. So we've got a set of strings that are in order, and we don't really care about the order in there. We're just looking for uniqueness because we want to basically just use these to be able to remove strings from the English language from the Hitchhiker's Guide to the Galaxy book, and then we get all our matches there. We get to find the most common English word that's not a common English word. So if we use the remove, so there's filter, which will return matching things, and remove, which will get rid of specific things. So we're removing anything that's in the set of common English words from the book so far, the split up words in the book. So we could do that after or before frequencies, because there's no point counting the frequencies of the words that we're going to remove, so we may as well remove them beforehand. Be slightly more efficient. So I'm going to remove common English words. Oh, did I not? Oh, I didn't evaluate that. Oh, yeah, so I put that in a def. So let me just evaluate that before I wonder why it's not working. Yeah, so we got, so I've basically taken that this function. This is how it works. How it looks normally in normal notation, and I've just basically given it a name, common English words, just so it's easy to use in here. Makes this algorithm a little bit easier to write, easier to read, common English words. There we go. And then I'm going to slurp in the results of sequencing the book. So that's, there we go. You can see that there. So that's, and then you can kind of see why it's kind of like sometimes it's nicer to use this threading macro, because it just makes it easier to follow through the order of what you're doing. If you're reading this, you kind of have to start in the middle and work out backwards in the kind of the classic list way of reading the thing here. So sometimes it's easier to actually read, but it does require you getting used to the threading macro. So if I remove the common English words, let's see. Let's evaluate this. And we can see, oh, we've still got I as the common English words. Oh, why is that the case? Oh, you can see that I is uppercase in here. And if we look at our common English words, they're all lowercase. So we can see that yeah, it's not going to strip out any uppercase common English words from our book. So we can add something in there. So we've got this. So one way to do that is just to convert everything to lowercase. That's probably the most sensible thing, because then one of our sources is all lowercase, and we can have both the book and the common English words list to be lowercase. Then they'll all match each other as well. So if we do boom. And so if we do that, yeah, before we remove, because there's no point doing it after we've removed them, because we'd have to remove them again. So if we convert the book to all lowercase, then that would be, I was just wondering if we could do that beforehand, but it'll do there. Oops. So here we're going to just map over all the strings in that we've broken out. So broken out all our big single string of a book into individual words. Then we are converting every word to lowercase. Then we can strip out all our common English words, and then we can cut the frequencies and then sort by value, and then reverse, so we get the biggest value at the end. And we get Arthur. And you can see Arthur did have a capital A at the start, and now it's got a lowercase, so you can see it's being converted. And for a book whose main characters are Arthur, Ford, and Zaphod, it's not that surprising that they are the three most non-common English words the most often used. Up, interesting, yes. And planet, it is about space. So planet obviously gets a good look in. Yeah, I wonder if yes, is yes a common English word? I'm not sure. And it's, maybe that it's wants to be, we might need to do something around that as well if we really were wanting to rule out different variations in that. So that we would just add that to the common English words, I think, there as well. But that's showing you kind of two different ways to use regular expressions to break up and play around and experiment with a big string. As initially, when we're slurping this in, it becomes a big string, and then we're breaking it down with a using reseek to create a new sequence based on this regular expression. And then we convert it onto lowercase, removing the common English words, which again we've got by taking a comma-separated list of English words. We're doing a split using a regular expression, and then just converting it to a set, just because it makes it easier for us to remove anything from the set, common English words, from the individual words that reseek generated for us. And then we've got all our words that are not common English words, so we can get the frequencies, sort by value, and as that's goes, so that sort by value starts at 1 and goes up, then we need to reverse so we can get the biggest number. And that's it. It's a very nice way of processing large amounts of text, and as you can see, it's pretty quick to give me the results, and it's a nice way to play around and experiment with the regular expression and see what the different results is it gives. And we can comment these particular things out if we wanted to try. So if we weren't interested in the lowercase, if we weren't interested in removing the common English words, we can just two functions out. So just using the hash underscore, which is the reader literal for a comment. And this would allow, so this is using the threading macro is another kind of advantage of using this, because you can just comment out bits of the algorithm that you're doing, and it will it will allow you to kind of see just what these uncommented functions are doing and how they work together. So it's quite a nice way to experiment with a kind of larger algorithm, so bringing together, I mean, these might be different functions you're actually composing together, which essentially is what it is doing. So you can kind of have them individually switched on or off to see what the effects are as well. I hope you found that useful. I'm going to publish this on the actually I've got a website which is if you go to github.com, I am going to publish these on, I think I'll put these on the Practicalli website. I don't think they're there yet, but I've got code. Oh yeah, I've got Clojure through code. There we go. I have moved them. This wasn't my own personal repository, but yeah, so Clojure through code on Practicalli. I shall upload the Hitch Hiker's Guide to the Galaxy, both versions there for you. And so if you just go into source, it should be there somewhere. Yeah, there we go. I'll update this with the new version, or the extra versions, extra explanations. There we go. Thank you very much for listening, and I shall see you next time. Thank you. Bye. Goodbye. Thanks.